Right, some quick announcement here. So I believe most of you have got some Moodle announcement from earlier this morning. For office hour, if you want to speak to me, just for today, the office hour has been moved. So go tomorrow instead. So tomorrow, Tuesday, 12:30 to 2:30 p.m. Okay, so just for this week. And then there was a Moodle announcement about lab test 1. The outcome, not so great. So that's why we decided to let you take it again. Hopefully that can improve your grade, but you gotta do some work to make it up. If you got any concern about your progress regarding lab test 1, speak to me. Okay, I can maybe speak to you in person to look at your submission, etc. But you gotta speak to me early. For ETF, as I mentioned, for your lab number 3, 4, and projects, you're gonna use the ETF framework. So it will be your best bet to specifically follow through all the tutorial videos. And notice that I put a new video just over the weekend. So that one is really about how you can automate regression testing to make sure everything works on the side of the Linux. And the Oracle we give to you is only runnable on Linux. So that's why I made that video to help you. If you got any trouble of following along the video 7, also can speak to me. Okay, that's gonna save you time. Also for lab 4 and projects. So today the plan, I would like to finish off the Singleton design pattern. And then I want to talk briefly about ETF, which is also quite important for the course. And then next time we'll start talking about some review of inheritance, and then design patterns will follow. Okay, so from before the reading week, for now I assume you actually studied why for the data sharing problem using inheritance is gonna violate 2 design principles. Remember, one is about cohesion, the other one is about single choice principle. We'll talk about them in detail before the reading week. Okay, I assume you know them already. So today we're going to continue from basically the once routine. Let me just remind you very quickly what's really the once routine Eiffel, and then we talk a little bit about how you can simulate it in Java in an imperfect way. Okay, not perfect. We're going to discuss that. Okay, let me talk about just a once routine right away. Let's say in any class, if you got usually you can either have the do option over here. For the do keyword, it will work just as normal. For that one, I don't need to bother you with the details. But let's talk about the once option over here. If you actually put the keyword once as opposed to do, so that simply means only the first call really matters for computation for the body. And all the subsequent call is going to return the same reference. So what do I mean by that? Let me show you the test case. So basically, the same test from last time before the reading week. So let me just show you the test quickly. Okay, I will show you the once version directly. Let's say for this particular class, we have a feature here called new once array. And that one is simply just going to return an array of string. Okay? And then the implementation over here is simply to say, I want to create an array of string, initially just empty. And then whatever arguments I receive, I'm just going to add it to the end of the array. Since the routine is actually once, that means you're only going to create this particular empty array and add it to the end only for the very first time. For all the subsequent calls to this particular once routine, you'll just return the same array reference. That's what's going to happen. Okay, let's just simulate it quickly. And then we got to use this for the Singleton pattern. Let's take a look. If you take a look at the test case, let's say, first of all, we got a.make. So a is simply this class over here. And then we say array number 1. Okay, that's the first one. So let me write it down. So ARR1 is now going to point to the return value of this particular new once array. And this is the very first call. Okay, and the very first call really matters. That's the only time you're going to take some computation to actually do the calculation. And in this case, you're going to pass Alan. So that means for the very first time, this will be Alan for the once routine. And then you will simply create the array empty to begin with, and then add it to the end, Alan. And then ARR1 is simply just going to point to that particular array, okay, like that. And under the hood, implicitly, there is a cache reference for this particular once routine, which means you can think about there is some reference that's maintained by the Eiffel runtime, which is to make sure all the subsequent call to this particular new once array, starting from the second call, they're only going to return back to you this particular reference, and no more computation will be done. Okay, that's the essence for the once routine. So that is why when you try the second call over here, okay, so new once array, so this will be the second call. You only have to distinguish between the first call and all the subsequent call, only 2 things. And what about this guy here? Even though we're giving Mark this time, so rather than Alan, it's actually Mark. So now the question is, are we going to execute the body of the implementation here anymore? The answer is no, because it's a once routine. After the first call, you don't do that anymore. So now what you will have is ARR2. You can think about ARR2 is just going to point to wherever this particular cache reference is pointing to. So ARR2 is just pointing to here. The good thing about the once routine is if the once routine returns a reference type, every call to the same once routine is going to return back to you the same reference. Okay, just keep that in mind. And we're going to use this for the singleton pattern question.
So does it modify the reference or just points to it?
It just points to it.
So is there any example? Does it warn you that you're doing that, or does it just do it?
What do you mean it will warn you? Warn you for what?
Let's say you're using the once array, you use it a second time by accident. When you meant to use it.
No, there won't be any warning. So you should really know what you're doing. As far as the compiler is concerned, right? You can see in both cases. Okay, let me just try to answer your question a little bit differently. You can see this is called new once array over here, and this one is using the once keyword. Another one is called new array. That one is using the do keyword. Calling each one of them is simply just going to return back to you an array of string. As far as the compiler is concerned, it doesn't make a difference. Just return value is array of string. But the behavior at the runtime is really up to you. I mean, up to what you choose to call. Okay? So you got to be careful. Okay? And for those of you who actually follow along the ETF tutorial, I did mention the ETF generated code supports the singleton pattern. So you'll see some once keyword over there. But we'll talk about the singleton pattern today to make sure everything will make sense. Okay, any question about the once routine? Yes? The once routine, okay, the usefulness for that is you're basically trying to call the routine just once, and then whatever computation result you get will be stored somewhere. Any subsequent call for the same routine will just use that particular computed result. So the good thing about it is you can use that to share data. You will see. You'll see exactly how we can use it. And well, one more thing to say before I get back to your question. Singleton pattern is not a difficult pattern here. It's just that you have to know about the once keyword and also how you can make sure there's no way for you to create multiple instances of the shared data. You will see what I meant in just a moment. We'll discuss that. Okay. Question?
So is it similar to having like static?
It's similar to static, yes, I agree with you. However, I'm going to show you two possible ways of using Java static, but they are not quite the perfect design just yet. We'll get there. But if you really want to think about the once routine similar to static, you can think of it, it's just like a global thing you want to store. Okay.
Let's say you've already initialized the first one. We've done ARR1.
Okay.
If you're doing the second one, do you have to have a parameter still?
Good question. Very good question. That's also something I briefly mentioned before the reading week. If you think about the first call, the pink one is the first call, right? I'm just using Alan. In this case, Alan is used to insert into the end of the array. That one's useful. On the other hand, all the subsequent call, if you pass maybe Mark over here, any call after the first one, the parameter is simply just ignored. So I would say typically in principle, as I mentioned before the reading week, you don't really want to have a parameter for your once routine. Typically you don't want it. You can leave it empty, yes, as you will see. In the singleton pattern, we does leave it empty. We do. Okay. Okay, guys, any question here? Actually made a very good point. Yeah, if the parameter is simply ignored from the second call, why do we need it? Yeah, but I just want to show the example, right? Yeah, that's okay. Right. Okay, so let's think about how we can simulate once routine to give you a little bit more understanding to compare different languages. If I try to do this in Java, how would you do it? I would agree with static. You want to give a little more details? How can okay, think in this way. I want to use the static keyword or static method or static attributes to simulate this particular once routine. How can I be sure only the first call is going to do some computation in the method body? All the subsequent call, somehow I'm going to ignore the body of the implementation and then try to just return the reference. Is it possible to do that in Java? Alan? Well, final is like a constant, right? So I don't think that will work. You might need some variable to keep track of the states to see Maybe initially I haven't called this routine even once. As soon as I call that for the very first time, maybe I should set the flag to be true, for example. Something like that. Okay, let's take a look. Let me now switch to a particular Java design. Okay, I'll mention that's exactly what I just mentioned, but let's talk about it. And then we're going to think about problem. Before that, let me just remind you one more thing. For the next two Java examples I'm going to give to you for discussion, here are the judging principles. Number one, we want to make sure we have cohesion. Number two, we want to make sure a single choice principle is also still obeyed. And number three, make sure there's only a single data instance. That's why they are being shared, right? If you can actually create multiple instances for the data, it's not being shared. Okay, single. Keep these three principles in mind. We're going to use them to judge. Now, let's look at the first Java version. Okay, I'm going to go over with you. If you look at that over here, let's see this. So we have a class called bank data. You can think about this as a data to be shared. And then we have some constructor over here. Just imagine that it's simply without any modifier, so it's visible within the package level. But that can also be public. That doesn't matter. And then you have some data called interest rate, for example. Also, you can set the interest rate. Okay, that's a bank data class. And then for this particular bank data access class over here, so this is the attributes I talked about previously, right? Let's say I have this particular flag called init once, initially just false, meaning that if this flag is simply just false, that means I have to go ahead and evaluate the body of the implementation. Otherwise, after the very first call, it should be set true. In that case, I don't go ahead to evaluate the body of implementation anymore, just return the reference, right? That's exactly the behavior we described in the once routine. So I'm saying that initially simply just false initially, right? So now we are saying that if we have not initialized just yet, thinking this way. So if we have not yet called this particular routine, which is supposed to be once, and we're going to do some initialization over here, do some computation, and then we're going to set it to be true, right? So now for the second call to this particular bank get data, in that case, the init once will now be true. In that case, we're simply just going to skip this particular part and then just return the data reference, right? It's doing exactly what we just mentioned. So now, if you think about in this way, let's say we have a tester over here, right? So you initialize maybe bank data over here, and then you say data is equal to bank data.get data, okay? This is the very first call. So that one there is going to execute the body of implementation over here. And let me just add one more line. I can say, for example, data2 is assigned to bank data access dot get data, the same method. So now what's going to happen over here to the second time? Yes? Yeah, you won't initialize it because now init would be set to true. In that case, you will bypass, right? That's exactly what's going to happen. So now over here, get data over here, because at this point, the init once at this moment is simply just true already. So you're going to bypass this particular part and then just return whatever data it is. That's how you share. Okay, that's a Java version. This will make sure, number one, cohesion. Cohesion is not a problem. Cohesion, as far as cohesion is concerned, it is good because we are separating between the data itself and also its access. We're separating the two notions. That's good. It's good for cohesion. Cohesion means you don't want to mix everything together into a single class. Cohesion is good. What about single data instance? I'll put a question mark here. In this particular design in Java, is it really possible to guarantee there's always only one single data instance available to us? Is it or is it not?
No.
I heard no. Okay, so why do you think no?
Because can't we just make like big data 2, like make a new big data?
By using the constructor directly, right?
Yeah.
Yeah. For this particular design, there's a very serious flaw over here. Okay, I'm going to highlight it. The flaw is exactly this line over here. This particular constructor for the bank data is being called over here by the data access. However, does it really prevent from any other classes from calling this particular constructor? Not really, because that's at the package level of visibility. So that means over here, I can definitely, I just add a new line over here. I can definitely say, let's say bank data, let's say data 2, okay? Rather than using the bank data access method to get the data, rather than using it, I can simply say new bank data. I'm just calling this bank data. And this will guarantee I just got a brand new instance from there. So I don't have sharing anymore because I got 2 possible instances. That will break the data sharing right away. Guys, any questions about this? Yes? What do you mean to start with bank data first? So in this particular design over here, you can see bank data itself is okay, but it's really about the constructor over here. The constructor over here is at the package level or being public. In that case, any class in the same package can actually call that, not just bank data access. So that's not good. So that means you can definitely create multiple instances. Jordan.
You could make it a static class inside the bank data access and make the constructor private.
Yeah, to make it a static class, I'm not too sure about that. Let's not go there. That's because it's a little bit too complicated. Yeah. Okay, any question about this? I just want to mention briefly. Okay, so here, even though we support cohesion, we separate between data access and data, but you can easily break the sharing data principle. Initially, it's false. Yes. The default value will just be false, the init once. Okay, so now how can we try to fix this? So let me try to fix this by saying, for those of you who might be, I'm not sure, I think that we used to cover the singleton pattern in Java in 2030, but we stopped doing that, since a few years ago. But in case you know how to do it in Java, one way to do it is by saying, what about, let's say this, since this constructor over here should only be called by this particular bank data access class, right? Presumably. So why don't we move it there? And then we can make this particular constructor private. So the second solution looks like this. So now we want to fix the problem about not every class can call the constructor for the bank data. That's the problem we want to solve. So what we do instead is like this. So now you can see this particular constructor here becomes private. So now in any other class, let's say if I have a class over here called tester, right? Just another class. Okay, let's say called the tester. And then if I simply say bank data and data, rather than using this particular get data method here, I simply say is equal to new bank data. In this case, it will be a compilation error because it's only accessible within this particular bank data access class, right? It's only within this particular class. So it's not even going to compile. That seems to solve the problem. But does it create other problem?
There's a minor thing. So you know how your bank data, get data thing is static?
Yes.
So if you have the bank data as an inner class within bank data access, then you can't instantiate the bank data because it's a basically it's a class that is dependent upon the bank data access.
Yeah, I don't really want to. Yeah, maybe that will work. Maybe we can talk about your particular solution. But since we don't cover nested class in 2030, so I can assume everyone knows about it. But I'm just using what you know already. Guys, so far any questions? So this effectively solves the single data instance problem. It's guaranteed only the bank data within it you can call the constructor only once. Okay. Now, any problem for this design-wise? Cohesion. Why? Yeah, exactly. So it's either I gotta separate them, and then I lose the single data and then I violate the single data principle. If I put them together, I violate this cohesion. It seems like one or the other. Wouldn't it be nice if there's a solution for both? Right? That's the logic. Okay, so for this particular guy here, okay, so now we are basically mixing, number one, okay, let me just be clear here. You can think about this particular method over here is doing data access. On the other hand, this part over here is doing the data itself. You're mixing these two things together in a single class. So it violates cohesion. Again, implementation for both versions actually work. However, this design is not perfect since we talk about design in this course. So we want to criticize on them. So now what we really want to have is a version where we can have both cohesion and also the single data instance. That's what we want to have. Okay? Let's see how we can do that. Okay. Any question about the Java version? Okay, and then I'll switch back to Eiffel. Question? Yeah, cohesion simply means you don't want to, well, every class should have a single purpose. You don't want to mix different purposes into the single class. In this case, you're mixing access and also data itself into the same class. It would be nice to separate them. At the same time, you want to preserve the single data principle. Right. All right. Okay, so now that's about it. So let's see how we can do it. Okay. In order to do it, we need to understand some constructs over here just to get you comfortable. Okay, so these are the two things we talk about. I also got some brief description on the slide. You can also study them. Okay. How do we do singleton pattern? Okay. Let me just go directly to how you can do it, first of all, and then I'll explain why that will work. Okay? And then I'll point out to you exactly what you should really pay attention to. And let me say this. Singleton pattern in ETF is already by default generated for the model access. However, it doesn't really mean you can only have just a singleton design pattern implemented there. You can feel free to create your own singleton pattern example in your ETF project. You might find it useful. Okay? For example, error handling. Remember in the tutorial video I said the one I suggested in the tutorial video may not be ideal. What could be a better design? Think about you're trying to make error message objects a singleton objects to be shared by all the commands. Think about this point. Okay? You can try that also in your lab or in your projects. Okay, let's look at how things will work together. You got basically three classes. Okay? First of all, we got cohesion for sure, because one is called data, the other one is called data access. So that's cohesion, right? You separate them, first of all. Okay? So the green one is talk about cohesion. So that one is satisfied. But now, how can we be sure only the data access class can actually make a call to the constructor for the data? That's something we want to make sure. So here's a trick. Okay? I want you to look at the two keywords over here. One is called the creates, the other one is called the feature, right? You got these two classes, right? These two are you quite familiar with already. What we do is we want to do some export status to really restrict them. Okay, so now let me write it down here. The first one here, I'll make it bigger. When you actually put this particular export status immediately after the create clause, so that means only this class can call the make over here as a constructor. I'll have more example for you in the next slide to give you more intuition. But for now, let me just write down exactly what that means. If you declare that particular export status immediately after the create, so that means only this class can call the make as a constructor. The second one to see, you can see this is a feature class, and in that section there's only a make routine over here, right? It's a command. And now the second export status here is also necessary. You need both. So this one here is to say only this class can call the make routine, right? That's the make we're talking about, as a command. So one of them we talk about, let me use a consistent color. So one of them we talk about command, the other one talk about constructor. Right? Let me just show you right away. Let's say I try the following. Okay? In this particular test feature, in another class, in the client class, right? It's outside the data and also outside the data access. If I try the following, let's say this. If I insert a line over here to say, I simply want to say creates, okay? And then I would say data, right? I want to create an instance of data using the constructor make. Let's say D3, right? Already got D1 and D2, dot make. And then, of course, I can give some initial value, for example, 23, let's say. So now, is this going to work? It's not going to work because according to the export status over there, I said only data access class can call the make as a constructor. But now in the test class, in the clients, I also try to call the make as a constructor. It will be forbidden by the compiler, so it wouldn't compile. Okay? That's the thing you want to pay attention to. I'm going to do some more example with you in just a moment, okay? Not compile. Because of this particular data access over here, okay? So this is a critical thing to really make sure we can achieve both cohesion and also single data instance, because now only the data access class can actually call this particular make feature, okay? You can see the result is of type data. So this is the only place where the make over here can be called as a constructor. Can be called as a constructor. That's the only place. Okay. And there's a minor thing I want to mention. Do you see there's a keyword expanded somewhere? Okay. I want to highlight it to you. Expanded. Can anybody tell me what's the usefulness for the expanded type over here, the expanded keyword here? What's so special about expanded versus reference? You don't need to make an object explicitly. So that means over here, now, when I actually got, for example, access over here, in the client class, I say access is of type data access. Do I need to explicitly create this particular data access objects? I don't need to, because it is expanded. So that's why it can directly say my D1 and D2, they're both data, right? But now I can simply say access without initializing it, just say access.data. So that's why expanded could be useful. Expanded is not so necessary for the singleton pattern, it's just a very convenience. Or let me put it another way. What if, for now, hypothetically, okay? What if I say I get rid of this particular expanded, let's say. What should I do? Well, is it going to compile if I just get rid of expanded? I heard no. Okay, anybody tell me which line in which class? If I simply got rid of expanded. Jordan, first of all, which class? The clients, maybe? You mean, okay, if I got rid of expanded, you're saying there will be some problem over here or another? Nope, not here. Data is fine, right? Data is just normal class, that's fine.
I meant the data access class.
Yes, so you say there will be a problem in this class or somewhere else? In this, over here, the client, right?
No. I'm saying, doesn't the data access class itself need a create?
That one there, not necessarily. You can, if it's not there, it just default creates.
Okay.
Yeah, you can think of it like a Java, right? If you don't have explicitly some constructor, there will be implicit, a similar idea. Okay, so there will be a problem over here if I didn't have expanded because you're trying to use the access over here without explicitly initializing it. So you would say the object, the target object might be void. Okay, because you're going to use a single data access in so many places, in so many classes, it might be a little bit annoying if you have to explicitly initialize them every time. That's why having expanded over here will be beneficial. Okay, expanded. So that's for that reason. Okay? But the most important thing for you to realize is two things. Okay? In order to make the singleton pattern work, number one, you should really make sure the data access is now declared properly. Okay, in the two places. Number one. And number two, we're also using the once keyword over here. So that is to make sure only the first time when you call the data, in this case, we don't have any parameter. right? So that means you don't have to worry about the parameter being ignored starting from the second call. If the once is over here, you can think about in this case. So when we execute this particular line, okay, let's say this line here, and this particular data here, this is the very first call. In that case, we're going to create this particular data instance, right? It's like a once. On the other hand, what about all the subsequent call include, let's say, over here? And this is basically a second call to the data, right? In that case, you're not going to execute the body over here anymore. Instead, you just return the reference to the data. Okay, so that will ensure only one single instance is returned for the sharing. That's how things work together. Any question? Okay, in order to maybe make you feel a little bit more comfortable, maybe I'm being too pessimistic, right? Why don't we do the following? Okay, let me start a clean page over here. Let's trace very, very quickly. Very, very quickly. Okay, the same block of code. Okay, let's now talk about the clients, right? Let's do line by line. If I talk about line number 1, so now when I say D1, D1 is a data, right? So now I'll say D1, it should be pointing to some data objects. So now how do we create that data objects? The way to do it is by saying access.data. So this will be the very first call to this particular once routine. So what we will do is we're going to call this particular constructor here just for the very first time, just that time. What that will do is it's going to create a data objects for the very first time. And data, and then make will just initialize the value to be 10. The value will just be 10. Okay, and then D1 is going to point to it. And implicitly, as I said, there will be a cache reference pointing to it under the hood, implicitly. Okay? Now, let's try the non-first call, or the subsequent call. Let's say purple. If I say D2, which is also data, is now equal to access.data. So now I'm calling this particular data for the second time. I don't have to implement this, I don't need to execute this anymore. I just bypass it. What that would do is simply we just return the reference for this particular cache version, right? What that would do is D2 is now going to point to just the same objects over here. Any questions? So the most critical thing to understand about once routine execution is only the first call matters for the computation. All the subsequent call, you just return the same reference. And then after this, if we simply say D1 equals D2, should be true, right? They point to the same objects, so that should be true. And then D1.v is 10, D2.v is 10, right? Not a problem. And now let's see how we can, since now the data is being shared, this particular orange data, if I try to modify the data by using any of the sharing party, it should be reflected to all the parties. So what I meant by was, so now if I try d1.change_v, right, it's a command, to 15. So I'm using d1 over here to change the reference, to change the value from 10 to 15, right? So now after that, d1.v will be 15. Also, d2.v is also 15, right? There's an alias going on. So that's a shared data indeed. Every time you call data for the subsequent call, it will just return the same reference. That's Singleton pattern. Guys, any questions for that? I hope that's clearer, I hope. Okay, study that. If you got further trouble, talk to me. I want to just mention something very quickly to get more idea, for you to get more idea. Okay, I want to just talk a little bit about export status. Sometimes students also got some confusion, how you can use the export status. Let me just try out different possibilities for you so you will see exactly how they can be used. It's not hard. It's not hard. So the way I'm going to illustrate this is by as follows. Let's say I have a supplier. The supplier simply got a command over here, right? This is a command. At the moment, I don't have any export status over here. I don't have any export status over here. It's as if I simply put any over here. As if. Like a public. So they're completely just public. Any class can call make as a constructor. Any class can call make as a command at the moment. Okay? So that is why, if you try that, you can see I got client 1 and client 2. Client 1 can call make as a constructor because I got creates. And also client 2 can also call make as a constructor, no problem. And I saw some of you actually doing the lab test 1. When you try to create an object, you forget about the create keyword. That's why your code wouldn't compile. Okay, just to mention that. And similarly, you can see for the client number 1, I can also call the make feature as a command. And client number 2, I can also call make as a command, right? So all these 4 occasions are allowed. So everything will just compile. Any question about this first version before I try to modify that a little bit? Yes? Yes, correct. You can think about create is like a new keyword in Java. So when you have create, that means you want to create a new objects. When you actually say s.make, for example, you assume s should be not void. Right. Let's modify this slightly to make it more interesting. So you can try all different combinations. Now, if the same block of code, let's say the following. For some reason, I decided the following design. I say client 1. And then here I say client 2. Okay? And then let's say I'll put the line number for you to identify. This is 1. This is 2. This is 3. And this is 4. 1, 2, 3, 4. In the previous version, 1, 2, 3, 4, all compile, right? How about this version here? Go one by one. Should 1 compile? Can client 1 call make as a constructor? Isn't that specified here? Client 1, right? No problem. What about number 2? No. How do you know? Yeah, exactly. You can see now we're calling, there's no create keyword over here, so I'm calling make as a command normally. And the only class that can call make as a command is client number 2. I'm calling the wrong context, so this is now going to not compile, right? Guys, you see the issue here, right? It's not too bad, I think, hopefully after this example. Of course, in the case of singleton pattern, we just make client 1 and client 2 to be the same class, data access.
So what's the point of being able to assign features to, like exporting features to a specific class if they're not in the make as well?
Which one?
So you're saying client 2 can access the feature make, but it can't use it as a constructor?
I would say, I'm just trying to show you syntactically what would be the thing you can do. Exactly what you may want to do it is completely up to your design. I'm just saying maybe for some reason, I only want the client 1 to be able to call to create objects. But client 2, they can only modify but not to create objects for some reason. Whether that reason is valid or not is up to your particular developments. Yeah.
My other thing was, how can you modify something if you can't create it?
Why not? You're just saying you're relying on one party to create the objects. And then you're saying you're relying on another party, different party, to actually modify objects only. It's more about access control, really. Yeah.
You could twin it and then reinitialize it, right?
Let's not get there. What do you mean? Yeah.
Well, couldn't you call twin on like an object that the client 1 already created and then?
It's interesting. But I think twin is a little bit different from make. I think it's a little bit different. Let me think about it. Get back to you. Yeah.
I was wondering about the earlier thing about how you were saying we can only make it in one spot.
Uh-huh.
Well, what if we create one and then we start twinning the one that's already created?
If you
It sort of break out of.
Yeah, definitely. Exactly. If you simply use twin, that means you're creating new objects.
Yeah.
That means you're breaking the single data instance over there. Yeah, that's not good.
So is there a way to restrict twin? Or?
As far as I know, you cannot really forbid a particular class to call twin. Twin is a very general method every class can call. Yeah, I'm afraid not. Yeah. In that case, maybe you should really write some appropriate contract to make sure you're not creating any new instance. Okay. All right, so now so now you should know that, so now calling this will be okay, and calling this will not be okay, right? It's completely opposite. Okay, any question about putting the export status over here? Any questions? Should we try another example? Yeah, question first.
For the client one, when you didn't create estimate, you put the integer as a parameter.
Yeah.
Will that still run even though create doesn't accept the parameter?
Well, okay, so now, talk about number one over here, right?
Yeah.
Okay, the reason that can accept an integer over here is because you can see make is accepting an integer, that's why.
Oh, I see.
Yeah, so over here, when you say creates make over here, you're not trying to redeclare the feature. You're just saying, for this particular feature, it can be used as a constructor. But now only this particular class can use it as a constructor. That's what it is saying. Okay, let's,
Question?
yes. Okay, for line number 4, okay, 3 and 4, okay? Think about how the compiler works in this way. When they evaluate line number 3, this is what's going to happen. If you look at this line here, are you trying to use make as a constructor or as a command? Constructor, right? Because you got to create keyword. So now, because you're using that as a constructor in the context of client 2, you look at this particular create class and see the list of classes. Does it include client 2? No. So that's why you would not compile. Okay, if you go to line number 4 here, so now here, since there's no create keyword, you're using make as a command. In that case, go over the feature class over here, go over the list. Does it include client 2? It does. So that's why it compiles. Yeah, so you're just talking about another issue over here. Since this, think about the client 2. Somehow they didn't really know about what they're doing. So they simply write down these lines of code and then simply try to get an Eiffel compiler to see whether they can be compiled or not. And then the compiler tells them, you cannot even do this line to begin with. So all the other lines, of course, wouldn't make sense. Of course, this line here, conceptually, you should compile, but it will not work at the runtime, as you pointed out, because you cannot even initialize S by using the make. Yeah. Okay. Okay, so that's about how you can use the export status, right? Hopefully that makes sense now. And then apply that into the singleton pattern. And there's one more thing I want to mention about a singleton pattern. Okay. Let me go back there. There's something I forgot to mention, which is very, very critical, right? And now somehow it's been polluted, so I want to just get another one, okay? And that one is very important over here. Okay, the same singleton pattern here. I'm gonna highlight this particular invariant over here. Let's take a look at here. If you look at the invariants for data access, what does that really mean? I say data equals data. Doesn't it look funny? Data equals itself. What does it really mean? This is a very critical invariant to have in order to make sure the single instance principle is actually being followed by this particular implementation. Okay, anybody try to explain to me that data equals data? Or let me put it this way. Would it work alternatively if I say, for example, alternatively, data tilde data, assuming that the is equal feature is actually redefined over here, just assuming that. And the way we redefine it is equal is by comparing their value for the integer. Okay, so now, excuse me, I'm talking about this is version number 1, and this is version number 2. Version number 1 is there, but what about version number 2? Would it work to actually ensure singleton data?
I would say no, because it's checking the actual location in memory, like the reference.
Why is that so important to check the actual location of the memory? Exactly. Okay, so the invariance over here is really crucial because, well, more precisely, you can think about data over here is one call to the data routine over here. The data over here is simply just another call to the same routine. And then we are saying that the two calls are returning the same reference. Right? So that's why it's so important to use equal sign here. And if we put on the exam, why would it not work if I simply put tilde over here? How would you explain it? If I simply say that. Huh? Yeah, sure. Yeah, counterexample is fine. Oh, how about this? Let me put it this way. I think it's really worth talking about this. Could be potentially on the exam, right? Could be. Why don't I put it here? Let's say I want to modify the design slightly, and then I simply say, rather than once, I would say maybe do. And then rather than equal sign here, I'll say tilde. Okay? Again, assuming that is equal is redefined over here, assuming that. Okay? So two questions over here, two questions. Question number one. Will there be any class invariant violation at the runtime if I try to execute this client code? Number one. Any class invariance violation at the runtime. Number two, is it satisfying single data, single instance? Two questions for you, okay, one and two. One at a time. What about number one? Would there be any class invariant violation? I heard no. Why would you think not no? Yeah, I would say, you know what, number one is a little bit tricky over here, so I would say you kind of, oh, actually, you'll be okay, yeah. Think about this. Sorry, let me take it back. You will be okay. Number one would be no. There will be no class invariant violation because when I try to call this data for the first time, you will simply just call this particular do body here, right? It's a regular routine, right? That one will simply initialize the data objects over here with initial value 10. And the right-hand side is just a fresh call to another data object, which is created, just normal routine. That will also initialize the value to be 10. Now, if I compare the two objects using tilde, that should be true, okay? However, having no class invariant violation doesn't really mean it's now implementing the singleton pattern properly. Agree? Because apparently you can see what I drew in orange there. You're creating two different data instances. That's not good. Okay? Yeah, think about this kind of issue here, right? So here, number one is no class invariant violation. However, if number two satisfies, no. Because separate data instances are created. Okay. So that's why the correct version should be this way. You say once over here, sorry. You say once over here, let me use a different color to highlight to you. You gotta say once over here, and then invariant, you really compare the references, right? These two are so important, okay? Okay, any question here? Yes? Okay, thinking this way. Let me just give you a different example. Just make it very easy. Class A, all right? And then I would say, let's say, I would say string. And then let's say do and end. Let's say creates result dot make. Okay, I can make a new string. Let's say every time I simply make a new string, let's call it just A. Okay, every time a different string objects. And now in the invariance over here, if I simply put S equals S, if I hit compile button, it would say no problem. It can be compiled. But at the runtime, exactly what was going to happen exactly, right? That's a problem. So now let's say we have another class called clients. For the clients, let's say this is a client side. Let me just declare, let's say A of type A. Remember, the first time to check the class invariant, as we talked about before, is when immediately after you have created the objects. So if I say creates, let's say A over here, assuming that this is some default creates over here. If I say create A, at the end of it, I'm going to check this particular invariant for the first time. What that will do is, it's going to look at S. S is not an attribute, agree? So what that will do is, it's going to execute the body of the implementation for the first time, right? Evaluation from left to right. And for this time, it's simply going to create a new string objects. And then it's just going to be a different object that's called A here. How do I evaluate the right-hand side? Again, it's not an attribute. So what I will do is I'm going to execute the body of the implementation here for the second time, because it's not once. So I gotta re-execute it. In that case, it's just going to create just another objects, brand new objects, and it will just be A. And then having left-hand side and having right-hand side, I'm comparing their references. Are they having the same reference? Not really. So if there's going to be a class invariant violation, that's how it is evaluated. So that's why it is so important to understand why this particular class invariant for the singleton pattern is really going to do some runtime check for you to make sure every time you try to call data, it's really going to return the same reference. Otherwise, you don't have sharing data. Okay, any question about singleton pattern? Okay? Okay, after this, also we talk about export status. You can review it. So now, basically, I'm not going to go any further because everything has been set. I just want to go over the design diagram with you in just a moment. Okay? But now for singleton pattern, right? We talked about this particular example already. And of course, now you can apply that to the bank data example we talked about. And this is the bank data example, just the same. Just different instantiation for the same pattern. And then I want you to think about this particular test code over here, right? To think about if I run through this particular test code, how is the singleton pattern going to work? I'll give you just some hints over here. So this is a test code over here, okay? So now if you look at the singleton pattern here, I'll make some notes here. You can see this is a once routine, and that's the data. And where is data called? In the client class, it's called account. Every account has some shared data. And then you can see we simply say data access dot data. So every time you try to create a new account, you basically try to call data once. So now, where will be the very first time that you try to call the data, the once routine? If you go to the test code over here, it turns out to be the very first account to be created is Bill. Okay, so now I'll make a note here. So this is the first call to data. Because when we try to create Bill, we actually have to execute this block of the code for the constructor of the account, and this is the first time we call data. Okay? And then, if you go further, this line, we are trying to basically, sorry, not this one here. This line here. It would be the second account. Do I have the second account? ACC2. I don't seem to have that. Okay, I think what I meant to do was, oh, sorry, over here. Didn't see it. The next line over there, I'm trying to create a second account. I say create and then ACC2.make. So now this is now the second call to data. So if I try to call that a second time, okay, I'm calling that the second time. Is it going to execute the body over here? Is it? No, because that's once. So that's why it's guaranteed. Only one single bank data instance is returned. Okay? That's singleton pattern. Okay, finally, I want to just go over the design diagram very quickly with you, right? Just some important thing to point out when you want to draw design diagram later. First of all, we got different packages over here. I simply say one package should one package for each client. Okay, and we got some application class, and then you also got the supplier of the shared data. Okay, under the supplier, we actually try to present the implementation or the design for the singleton pattern. So you got one class called data access, you got another class called data, right? And then make sure in the data you explicitly spelled out. So this is export status for using the constructor. And this is export status for using the command, right? So these are the two important things. And then in the data access part, you say I'm using once routine for the data creation. And then the invariant over here to say data equals data, right, by reference, right? These are all the ingredients for the singleton pattern. And one more thing to show you, two more things actually. Data access over here because it returns a data. So there is a client-supplier relation over here. And then it simply say data, right? Client-supplier. And then one more thing to say. Remember we said previously, let me show it to you. Because when you draw the arrow, you gotta be careful. Let's go back to this particular class over here. What's the type for access over here? Data access, of course. But remember, data access in our case is declared as expanded. So when you draw client supplier to say my target type is rather than reference type is an expanded type. The arrow is a little bit different. Okay, just some graphical notation you have to follow. Okay. So now in this case, if I go back to the design diagram, that's why you saw the arrow looks a little bit different. You can see there's a diamond over here on this end. Okay, so this one simply tell you it is expanded. Okay, so that's about the design diagram for the singleton. Okay, any questions do you have before I move on? So we're done with singleton pattern. We're done. So now, whatever that remains, I'm going to talk about the ETF. Question? Mm-hmm. Okay, sure. So what I just said, in your lab 3, 4, and the projects, you may want to consider maybe support error handling using a singleton pattern. Okay, I'll expand it a little bit. That's fine. Okay, what I would do is I'm going to expand this a little bit here. That's an error handling. It's only a suggestion. You don't need to follow. I'm just saying this is here. Let's say error handling using singleton. Okay, so now the principle will be there's only a single shared error objects at the runtime. Okay, that's something we want to achieve. Okay, how do we support this? By using singleton pattern. Okay, I'll just draw quickly what you should really think about. Okay, number one, we should have maybe one class called error. Oh, I should put it here. Okay, that should be effective, right? Let me put it on the right-hand side. One class is called error. And then we got another class over here called error access. Okay, that's also a plus. Okay, so now apparently there should be a constructor for the error, right? A make. And now you got to be careful because now we want to restrict two things. Only the error access can call the make as a constructor, and also only the error access class can call make as a command. Right? These are the two things, right? So you might want to put over here to say creates, and then over here you'll be restricted to error access. Okay. Similarly, let me put it down. You also have feature over here. This is where the command is defined. Also restricted to error access. Right? So this part is done. And then for the error access over here, you also got maybe a feature over here called error. Okay, and the error, tell me something. What's so special about error? Should it be once routine? Should it be regular routine? Once routine, right? You want to make sure every time you call this, it's going to return back to the same reference. So it's going to be a once routine, okay, and etc. And then there should be a client-supplier relation over here, and then that one maybe call that error. Okay? And now, every other class in your ETF universe, you can simply get access to this particular singleton error objects by calling error access dot error. Okay, I'll give you one example. Let's say, for example, if I got my let's say ETF. Let's say for your tutorial example, let's say ETF deposit, right? Let's say that's one of the command class, ETF deposit, right? What I can do over there is there will be a feature there called deposit, right? With some argument here. So now for the local variables, I can simply say error EA, error access. And then there should be error access over here. And then that'll be end. Assuming that error access is an expanded class. In that case, I can simply say maybe EA dot error. Okay, so that will guarantee from every command class, if I say EA dot error, is getting the same error message over there, the same objects. So you don't really have duplicate copies over there. Okay, make sense to you? Okay, any other question about singleton? I think quite a nice, useful pattern here you want to get used to. Okay, but understand why we have to get to this far about having export status, all things like this is for design rationale over there that we talk about. Okay, I want to talk quickly about ETF. Okay, I do have some lecture here. Okay, let's say within 20 minutes we should finish ETF. But I want to mention some tips for you as well for your labs and also the projects, which is also very important. It's a very brief lecture, okay, very brief. Okay, about ETF. I'm assuming that you at least started to watch the tutorial video for ETF, right, during the reading week. If you haven't, you want to do it, right? It's really going to save you time. You don't want to struggle just because you didn't have time. You want to watch that. Okay, for ETF. One, what will be the motivation of having an ETF? Basically, it's a very powerful framework for you to build prototype quickly. Let's say this. You want to build some application for ATM machine. Okay? Apparently, you can see the user interface here is a touch screen over here. In order for me to build up something quickly to know if that works or not, I don't necessarily have to adopt the concrete user interface here, like a touch screen, or make it a little bit more relevant to your study. Remember in 1022, in order for you to test your mobile app, you actually have to load it to your tablets and then to test it with the GUI. But for the ETF, it's actually to really test it using some abstract user interface, okay, without the actual concrete user interface. So what do I mean by that? Okay, so now we want to have separation of concern. Concrete user interface is simply what you have to build concretely, like a web app, mobile app, or desktop app. So this user interface will take some time to build, which will eat up your time for your developments. You may want to do it in the final step when you are pretty sure the logic for your model is actually correct before you try the GUI. GUI should be the last step, okay? And then business logic, the model is really the meat for your development. That's something you want to pay the most attention to by doing unit testing and also acceptance testing. Okay, so now you want to make sure you want to test your software way before you try to develop the GUI. Okay, so this slide here just is a general message for you. When you want to do your developments, you don't necessarily have to build a final GUI right away. You can build some quick prototype to make things work right away, quickly. Okay, so now what about the idea for ETF? Okay. What I would do is so this slide is easy. What I would switch to is some iPad, okay, here to show you. Okay, for every ETF framework you're using, think about as follows. The internal over here, I'll explain that in another page. Okay, but just imagine that when you do your ETF, the internal architecture is quite sophisticated, but for the external user or your customer, you got some input, you got some output over here. Input typically would just be a file. Okay, we call each input maybe AT01.txt. Right? It's called an acceptance test. And one important feature about each acceptance test is there'll be no syntax of any programming language. No syntax of a specific programming language, which means your customer can simply write acceptance test themselves and pass to you and ask you what would your program produce. In this case, I'll say I want to create a new account, create another new account, deposit, and do some transfer. Right? So this is something that any customer, even without any knowledge about Eiffel or Java, they can write and then ask you what will be the outcome. Well, they can say they write this particular test case for you and then tell you what the expected outcome should be, and then you program that accordingly. That's basically what you have to do for all the labs and projects. Okay? I'll talk about Oracle in just a moment. Okay? It's also important. So that's about the input, just a list of events. Every event is more like an interaction with the GUI you can think about. Let's say you can think about the new here is more like you're trying to click on the button of your ATM to say, I want to create a new account. Okay? And now the output here is really important here. The output here is basically like an interaction log with the system. Okay? The one I put in green. Okay? So these are the green ones over here. They're all over here. They are like events. They talk about different interaction with your system. The red one is really important. The red one over here, you can see it here, here, and here. So these are called the abstract states of your system. You can think about the abstract state as like it's like a representation of your current state. For example, in this particular case, I say initially, my bank simply got an empty set of your accounts. After the first interaction over here, after I have created Alan as a new account, now I got just, let me just clear it up, otherwise it's too messy. Okay, let me clear that quickly. So now thinking this way here. Initially, the account is simply just empty. After creating a new account, now I have a single account. Alan, and the balance is simply just 0. So this is like an abstract representation of your object states, right? So currently I just have one new account. Depending on the application you're programming with, like a Lab 3, you have different way of representing your states. After another new account, and then you got Alan and also Mark, and etc. So in order for you to really make progress on your Lab 3, study how the abstract state should look like. And for lab number 4 in the project, the abstract state is even more sophisticated. So now understand the structure for that. Okay? How do you understand it? 2 ways. Number 1, read the instruction. We do talk about some general structure. Number 2, you want to consult with your customer. And who are your customer? Either you can consult with me, your instructor, or you can just consult with Oracle. Oracle is really an authoritative guide to tell you what should be the expected outcome. Okay? Any question about just ETF in general? I haven't talked about internal structure just yet. I'm just saying you can think about from the external user's point of view, just input and output. Input file and also output file possibly. And the output contains a log of the interaction. Okay? All right, so now let me go a little bit further. So this is on the slide. I just want to talk very briefly. Okay? This is the whole process of doing ETF. Okay? Let me tell you what you are given typically. Typically, you are simply given the one in green. You're basically given a grammar file in order for you to actually generate an ETF project. Right? So this part here is completely given to you. Right? That's what you have to do to generate a tutorial example or to generate a lab. Okay? The green one is completely given to you. And now, what you really have to do, mainly 2 things. Number 1, you have to develop the business model yourself to think about what might be the best design for my model cluster. In your previous Java courses, usually you are told what classes you have to create. We even tell you the signature of the method. But now in this particular lab, we give you complete freedom to practice. How this model cluster should look like is completely up to you. So there are 2 parts for the labs and project we want to evaluate you. 2 parts, okay? One is about, okay, I'll write it down. 2 things. Number 1 is architecture. Oh, let me say in this order. 1 is about correctness. Correctness simply means we're going to take your ETF project, compile that, make sure it compiles, and then we give one input and see whatever you produce is going to match our expected outcome. That's correctness. In which case, we don't worry about how you design your classes, number one. Okay? Number two is about architecture. For lab number 3 and 4, you only have to supply like a bound class diagrams to present your design. However, for the project, you have to judge further about why my model classes should be designed in such a way. For example, if there's only a single class called ETF model in your model cluster, we can immediately tell it's a very poor design. It's a Superman class. So what you really want to have is have maybe some inheritance hierarchy or maybe some client-supply relationship, right? So these are the two parts we're going to judge your submission. Okay? Keep this in mind. For number one, you can always do the test, which I'm going to talk about how you can do regression testing. For number two, how can you give feedback about your design? I think that's why you're taking this course. That's the most valuable thing about doing these exercises. The best way, speak to me. Present to me your design, and I'll give you feedback. Maybe I'll tell you, maybe you shouldn't really have this big class. You should split them up into different classes. For number two, I rely on you to get in touch with me. Okay, so now a little bit more. There are also something called use cases. Okay, let me use a different color here. The pink one is use cases. I would say the pink one is both given and also something you want to come up with yourself. For lab number 3, we only gave you, I forgot, either 2 or 3 test cases. However, you shouldn't be too happy if your program can just work for those 2 basic test cases. So what we rely on you is to say, apart from maybe the AT01 and AT02 that were given to you, what you should do is you should really come up with maybe from AT03 all the way to, I don't know, AT99, for example, right? All the test cases should be come up on your own. You should be responsible for the correctness of your code. And now here's a question, right? If you actually got AT03 up to AT99, since these are not given to you, how do you know what the expected outcomes should be? How do you know? Either you can ask me, but if you ask me, I will simply say, check the oracle, right? Because I don't necessarily know what should be the precise one, character by character. You should really ask the oracle. Okay, I will have a more detailed page for you. Okay? Anyway, and then every time you want to do some test over here, you want to make sure if things are not as expected, you should always try to debug. Okay? That's a workflow. Anyway, the diagram is on the slides. I want to talk about 1, 2, 3. 3 more things, okay, quickly. Okay, so you're set for the ETF. In the ETF architecture over here, as I said, you should really pay 100% attention to how you design this particular model cluster over here, right? I would say you can definitely start with maybe by renaming this particular ETF model into something that's informative. For example, for your lab number 3, for example, you may rename it to maybe just maze. So that'll be the entry point for your model. And then everything will go from there. Okay? And then we also got ETF model access. Now it makes sense to you. There's only a single maze in your system using Singleton pattern. Right? So now, since we also cover Singleton pattern. Okay? Again, if you want to know about whether the pink one you design is good or not, speak to me. Okay? Now, this is really important. Yes, question?
This is about the bond diagram that we can do.
Mm-hmm.
Like, how much of the bond diagram do we have to kind of create?
How much? Okay. I would say the most important part, I would say as far as the user command is concerned, as long as you can include, let's say for lab 3, right? Remind me what commands do you have? You got move. So you got ETF, move, abort, ETF, abort, and etc. Not many, right? For this particular cluster, as long as you can draw this particular inheritance hierarchy over here, and then to show that you have a client supplier from the ETF command at the top level into the entry point for your model class, you're safe.
But then say, for example, with, you know how it references graph and all those other all the classes like maze drawer and stuff, do we have to reference those?
You may want to do it as well, because for lab number 3, maze drawer also a very critical part for your design.
But then say maze drawer references other things.
I would say how detailed your diagram should look like, I would say draw something first. Come to me, I'll give you some feedback. That'll be the best way, yeah. But I would say when the TA actually try to grade your submission, for this particular user command cluster, as long as your structure looks like this, you're safe. That one is not tricky, right? That's not what we are aiming for. What we're really aiming for is to look at the structure of your model cluster over here. You should show all the classes that in your model cluster, right? That's why you should really start drawing earlier. Okay, so now final two things I want to mention quickly, right? About acceptance test, okay? As I mentioned before, each acceptance test, like AT01 over here, you can think about this is a particular scenario that your customer is concerned about. And then the corresponding output, expected outcome, should be what the customer expects to happen. You want to make sure for every possible scenario you can come up with, you are meeting the expectation, right? That's kind of the principle. So now this is also covered in detail in video number 7. Okay, I just want to briefly mention that if we have time. Okay, we got about a few minutes. Mention quickly. At the end of the day, what you will have is like this. You got AT01 all the way to AT99. Maybe only these two are provided to you. You can just to get you started. All the rest you should come up with on your own. And then, how do we, first of all, your program is going to create outputs based on each one of them. So we just call it actual. Okay, that's a naming convention. So the green one are simply just the actual outputs of your program, which may or may not be correct. How do we know if your program is correct? We have to compare against the expected outcome. How do you know the expected outcome? Oracle. The Oracle over here, you can think about it is some executable that represents the customer. So every time you are not too sure about a particular outcome, just ask the Oracle. That's why we gave that to you. And then the Oracle is also going to produce for every input file some expected version. And then what we will do is we're going to compare one by one to say expected number 1 should match actual number 1, and etc. Right? And you really don't want to proceed with this kind of process manually, because every time you make a change to your program, you want to rerun all the 99 test cases. If you do it this manually, you can be annoyed very soon. Okay? So what I recommend is like this process. I'll just mention one final thing. What I recommend is like this. Okay? I believe most of you have set up your GitHub account already. Maybe? If you haven't, I would suggest now might be a good time to really get practice this particular good process. The constraint you have is this. The Oracle is only executable on the Prison Lab, only. We don't distribute Mac version or Windows version. I tell you what is the reason. Because at the end of the day, your program will only be tested in the Prison Lab account. If we also give to you Windows version, Mac version, there might be some embedded special character there. That might be inconsistency. So that's why we didn't do it. Anyway, the Oracle is only on a school computer. And in your home copy here, you can do as much development and debugging over there. That's not a problem. That's fine. I do that as well myself. So now, how can we make sure the green and the red are actually made inconsistent? Are made consistent, not inconsistently. You want to keep consistent copy. And one way to do it is by using GitHub, which can back up your file and also provide version history. You can always roll back to some previous changes. So here goes the flow. Every time, if you try to make a change on your home copy, right, what you should do is you want to push and you want to commit your changes to the GitHub copy. And then you want to pull it to your school computer. And then, assuming that you got wireless connection, right? That's the only assumption I'm making. Hopefully that's reasonable. And then in your school account remotely, you're going to run the Oracle and also regression testing, which means for regression, you're going to run all acceptance tests and make sure everything is fine. Conceptually, that's what you have to do. Maybe for every single change you make, you want to commit, pull it, and rerun the regression tests. You don't really want to only do the testing at the end of your development. That's too late. Okay? To really have more details, maybe watch video number 7. That one show to you the details. Okay, any questions? Okay? Okay, from Wednesday, we'll start talking about inheritance.